You're watching Elon Musk promise to put humans on Mars by 2026. You're seeing NASA's confident timelines for the 2030s. You're believing that Mars colonization is inevitable, just a matter of time and money. But what if I told you that every single person planning to travel to Mars will die before they ever set foot on the red planet? Not because of accidents, not because of equipment failures, not because we need better technology, because Mars travel is physically impossible. And everyone promoting it either doesn't understand the physics or they're lying to you. The math is brutal. The biology is unforgiving. The engineering is fantasy. And when you see the real numbers, you'll understand why no human will ever walk on Mars. Not in 2026, not in 2030, not in your lifetime. Possibly not ever. Elon Musk promises to put humans on Mars by 2026. NASA says they'll have boots on the red planet by the 2030s. Every space agency on Earth has detailed plans for Mars missions, complete with timelines, budgets, and confident projections about human colonization. But what if they're all wrong? What if Mars travel isn't just difficult or expensive or dangerous, but actually physically impossible with any technology we could realistically develop? Because when you look past the marketing hype and examine the real physics of interplanetary travel, a disturbing picture emerges. The challenges aren't just engineering problems waiting to be solved. They're fundamental barriers imposed by the laws of physics themselves. And those barriers might be insurmountable. You've been told that Mars travel is inevitable, that it's just a matter of building bigger rockets and solving a few technical problems. But that's not the whole story. The whole story is much darker. The first problem is distance. Mars isn't just far away. It's unimaginably far away in terms of human survival requirements. The closest Mars ever gets to Earth is about 35 million miles. But that closest approach happens only once every 26 months, and it lasts for just a few weeks. Most of the time, Mars is much farther away. At its farthest, it's 250 million miles from Earth. That's like traveling around Earth's equator 10,000 times dot. This means that any Mars mission has to be perfectly timed to launch during a narrow window when Mars is relatively close. Miss that window and you have to wait over 2 years for the next one. And even during the optimal window, you're looking at a journey of at least 6 to 9 months. But here's what they don't tell you about those 6 to 9 months. They might kill you before you ever reach Mars. Space is trying to kill you every second you're in it. It's not just empty void. It's filled with radiation that your body has no evolutionary defense against. On Earth, we're protected by a magnetic field and atmosphere that deflect most cosmic radiation. In space, you're completely exposed. During a Mars journey, astronauts would be bombarded with galactic cosmic rays, solar particle events, and other forms of radiation that would damage their DNA, increase their cancer risk, and potentially cause acute radiation sickness. NASA's own studies show that a round trip to Mars would expose astronauts to radiation levels that exceed their career limits by 1,000%. This isn't just increased cancer risk. This is radiation poisoning that could be fatal during the mission itself. And there's no realistic way to shield against it. Effective radiation shielding requires either magnetic fields as powerful as Earth's, which would require massive energy systems, or thick physical barriers made of heavy materials like lead. Either approach would make the spacecraft so massive that no rocket could launch it. Some proposals suggest using water or fuel as radiation shielding, but the amounts required would make the spacecraft impossibly heavy. You'd need several feet of water surrounding the crew compartment to provide adequate protection, adding hundreds of thousands of pounds to the spacecraft mass. But radiation is just the beginning. The human body starts falling apart in zero gravity within hours of leaving Earth. Without gravity constantly pulling on your bones and muscles, they begin to deteriorate rapidly. Astronauts on the International Space Station, which orbits just 250 miles above Earth, lose bone density at a rate of 1 to 2% per month. They lose muscle mass even faster. And this is with a carefully designed exercise program that takes several hours every day. On a Mars mission, astronauts would be in zero gravity for 12 to 18 months just for the round trip, not counting time spent on Mars itself. By the time they return to Earth, their bones would be so weak that they might not be able to support their own body weight. But the bone loss isn't even the worst part. Zero gravity causes your cardiovascular system to decondition. Your heart becomes weaker because it doesn't have to work against gravity. Your blood pressure regulation fails because there's no gravitational pooling to overcome. Astronauts returning from 6-month ISS missions often can't stand up without fainting when they first return to Earth. They require weeks or months of rehabilitation to regain basic physical function. After a Mars mission, this deconditioning would be so severe that it might be permanent. And then there's the psychological impact. Imagine being trapped in a small metal box with the same few people for over a year, knowing that if anything goes wrong, you can't go home. There's no rescue mission possible. If your spacecraft breaks down or you have a medical emergency, you're going to die millions of miles from Earth. NASA has studied the psychological requirements for Mars missions, and the results are sobering. The isolation, confinement, and stress would push human psychology to its breaking point. Even with careful crew selection and training, the risk of severe psychological breakdown during the mission is extremely high. But let's say somehow you solve all these problems. You develop perfect radiation shielding, artificial gravity, and psychological preparation. You still face the fundamental problem of fuel. To get to Mars, you need a massive rocket capable of accelerating a heavy spacecraft to interplanetary speeds. The Apollo missions required the most powerful rocket ever successfully built just to get 3 astronauts to the moon for a few days. Mars is hundreds of times farther away and would require a mission lasting years. The fuel requirements are staggering. Chemical rockets, which are the only type we currently have that work reliably, follow the tyrannical rocket equation. To go faster or carry more cargo, you need exponentially more fuel, and that fuel has mass, which means you need even more fuel to accelerate that fuel. To carry enough fuel for a Mars mission using current rocket technology, you'd need to launch dozens of separate missions just to assemble the fuel supply in space. Each launch costs hundreds of millions of dollars and has a significant failure rate. The economics are impossible. Some proposals suggest manufacturing fuel on Mars from the atmosphere, but this requires bringing an entire chemical processing plant to Mars, which brings us back to the mass and fuel problem. You can't manufacture fuel until you get to Mars, but you need fuel to get to Mars in the first place. Electric propulsion systems like ion drives are more efficient, but they're also much slower. They could take years to reach Mars, making the radiation and biological problems even worse. Nuclear propulsion might work in theory, but we don't have nuclear rockets, and developing them would require solving massive technical and political challenges. Nuclear thermal rockets would be more efficient than chemical rockets, but not enough to fundamentally change the equation. Nuclear pulse propulsion, like Project Orion, might provide enough power, but it would require detonating nuclear bombs behind your spacecraft. The engineering challenges are enormous, and the political challenges are probably insurmountable. And even if you solve the fuel problem, you still have to solve the landing problem. Mars has an atmosphere, but it's too thin to allow conventional parachute landing for large spacecraft and too thick to ignore completely. You're in this worst of both worlds situation where you need complex landing systems that combine parachutes, rockets, and possibly other mechanisms. Every Mars landing attempt has been extremely difficult, and most have failed. Even small robotic probes frequently crash. Landing a spacecraft large enough to carry humans and their life support systems would be orders of magnitude more difficult. The spacecraft would need to survive months of space travel, then perform a perfect landing on the first try with no possibility of practice or multiple attempts. Any failure means the crew dies. But let's say you somehow solve all of these problems too. You develop perfect radiation shielding, artificial gravity, nuclear propulsion, and reliable landing systems. You still have to survive on Mars itself. Mars is not a friendly place for human life. The atmosphere is mostly carbon dioxide with almost no oxygen. The atmospheric pressure is less than 1% of Earth's, so low that your blood would boil if you were exposed to it without a pressure suit. The temperature ranges from about 70 degrees Fahrenheit in summer at the equator to minus 195 degrees Fahrenheit at the poles in winter. Even in the warmest locations, it regularly drops below freezing. The soil contains toxic chemicals called perchlorates that would poison anyone who ingested them. These chemicals would contaminate any food grown in Martian soil and would pose a constant threat to human health. There's no liquid water on the surface, although there might be ice deposits that could be melted. But accessing and purifying this water would require complex equipment that would have to be maintained in the harsh Martian environment. Most critically, Mars has no magnetic field and almost no atmosphere, so the surface is constantly bombarded with radiation. Living on Mars would be like living inside a nuclear reactor. The cancer risk would be enormous, and genetic damage would be passed on to any children born on Mars. To survive on Mars, humans would need completely enclosed habitats with closed-loop life support systems. These systems would have to recycle air, water, and waste with near-perfect efficiency because there's no outside environment to fall back on if something goes wrong. We don't have technology that can do this reliably for years at a time. The International Space Station requires constant resupply from Earth to maintain its life support systems. A Mars habitat would need to be completely self-sufficient, with no possibility of resupply or rescue. And what happens when critical systems break down? On Earth, you can call for help or find replacement parts. On Mars, you either fix it yourself with whatever materials you brought with you, or you die. The psychological impact of living in such an environment would be severe. You'd be trapped inside artificial habitats, never able to breathe fresh air or feel natural sunlight. The sensory deprivation and isolation would drive most people insane. But even if you could survive on Mars, there's still the question of getting home. The return trip faces all the same problems as the original journey, but now you have to launch from Mars instead of Earth. Mars has lower gravity than Earth, which makes launching easier, but there's no infrastructure on Mars to support rocket manufacturing and fueling. You'd have to bring everything you need for the return trip, which means your original mission would need to be even more massive and complex. Or you'd have to establish fuel production on Mars, which requires building and maintaining complex industrial equipment in the hostile Martian environment. This equipment would have to work perfectly for years, with no possibility of replacement or repair from Earth. The more you examine the details, the more impossible the whole enterprise becomes. Each problem requires solutions that create new problems. The mass requirements spiral out of control. The complexity becomes unmanageable. The risk of mission failure approaches certainty. And this assumes we're only talking about sending a few astronauts for a brief visit. The idea of permanent colonization of thousands or millions of people living on Mars is pure fantasy. To support a permanent colony, you'd need massive infrastructure, power plants, manufacturing facilities, life support systems, transportation networks, medical facilities, and much more. All of this would have to be built and maintained in an environment that's actively trying to kill you. You need to transport enormous amounts of equipment and supplies from Earth, which would require thousands of rocket launches. The cost would be measured in trillions of dollars, and the technical challenges would be unprecedented. And for what? Mars has no unique resources that couldn't be obtained more easily from asteroids or the Moon. It's not a backup for Earth in case of global catastrophe, because any catastrophe that made Earth uninhabitable would leave it still more habitable than Mars. The romantic vision of Mars colonization ignores the fundamental physics and biology that make it impossible. It's based on wishful thinking and sci-fi fantasy rather than engineering reality. This doesn't mean we should stop exploring space. Robotic missions to Mars are incredibly valuable for scientific research. Orbital habitats, lunar bases, and asteroid mining might all be achievable with technology we could realistically develop. But Mars is a bridge too far. The distance is too great, the environment is too hostile, and the technical challenges are too fundamental. We might eventually develop technology that makes Mars travel possible, but it would require revolutionary breakthroughs that are decades or centuries away. Until then, Mars will remain what it's always been, a fascinating object of study from a distance, but not a destination for human travelers. The red planet will keep its secrets, and humanity will keep dreaming of reaching them. But physics doesn't care about our dreams. Physics only cares about what's possible. And Mars travel, as it turns out, is not possible, not yet, maybe not ever. The universe is vast and full of wonders, but it's also full of barriers that can't be crossed with determination alone. Mars is on the other side of one of those barriers. And that's why, despite all the promises and all the plans, humans will not be walking on Mars anytime soon. The red planet will remain red, distant, and impossibly out of reach. But the Mars travel impossibility goes even deeper than the engineering challenges. There are fundamental biological barriers that no amount of technology can overcome. Human pregnancy and childbirth in space or on Mars would be catastrophically dangerous. The radiation exposure would cause severe birth defects or fetal death. The lack of gravity would prevent normal fetal development. Any attempt to establish a permanent Mars colony would require solving reproduction in an environment where human reproduction might be impossible. Even if adults could somehow survive the journey and temporary residence on Mars, children born there would face devastating health problems. Their bones would develop incorrectly in a low-gravity environment. Their cardiovascular systems would be unable to function properly if they ever returned to Earth. They would be permanent exiles, adapted to an environment that could never truly support human life. The genetic implications are terrifying. The constant radiation exposure would cause cumulative DNA damage across generations. Children born on Mars would have higher rates of cancer, genetic disorders, and shortened lifespans. Within a few generations, Mars colonists would no longer be recognizably human. This isn't speculation. It's basic biology applied to extreme environments. We can see similar effects in animals exposed to much lower levels of radiation and altered gravity. The human body is exquisitely adapted to Earth-specific environmental conditions, and those conditions can't be replicated on Mars. But perhaps the most devastating argument against Mars travel is the economic impossibility. The most conservative estimates for a Mars mission start at $500 billion. More realistic estimates approach $1 trillion or more. To put this in perspective, the entire Apollo program, which only sent 12 people to the moon for a few days each, cost over $280 billion in today's money. Mars is hundreds of times more difficult and would require orders of magnitude more resources. This level of expenditure would require international cooperation on a scale never before achieved. Every major economy would need to dedicate enormous portions of their GDP to a project that offers no economic return and massive risk of total failure. The opportunity cost is staggering. The resources required for Mars travel could instead solve climate change, eliminate poverty, cure diseases, or develop sustainable energy systems. Sending a few people to die on Mars while Earth faces existential challenges would be the ultimate act of misplaced priorities. And the technology required for Mars travel would take decades to develop, if it's even possible. The research and development phase alone would cost hundreds of billions of dollars with no guarantee of success. We'd be committing vast resources to solving problems that might not have solutions. Meanwhile, robotic missions continue to provide incredible scientific value at a fraction of the cost. The Mars rovers have revolutionized our understanding of the red planet while costing less than a single human mission would cost. Automated systems don't need life support, don't suffer from radiation exposure, and don't need to return to Earth. The scientific arguments for human Mars missions are weak compared to the scientific arguments for robotic exploration. Humans add enormous complexity, cost, and risk, while providing minimal additional scientific benefit. Advanced robotics and artificial intelligence could explore Mars more thoroughly and safely than human missions ever could. But the final nail in the coffin of Mars travel might be time itself. The window for Mars missions is closing due to increasing solar activity and worsening space weather conditions. As our sun enters more active phases of its cycle, the radiation environment in space becomes even more hostile. Climate change on Earth is also accelerating, demanding immediate attention and resources. The political and social stability required for long-term Mars mission planning is disappearing as societies face increasing environmental and economic pressures. By the time technology might theoretically make Mars travel possible, Earth's circumstances might make it impossible to dedicate the required resources to such an endeavor. We might miss our chance entirely due to timing and competing priorities. The psychological impact of this reality is profound. Humanity has always been a species of explorers, driven to push beyond known boundaries. The idea that Mars might be forever out of reach challenges our fundamental sense of progress and possibility. But perhaps this limitation is exactly what we need to hear. Perhaps the impossible dream of Mars colonization has distracted us from the possible dreams of Earth restoration, ocean exploration, and sustainable development. Perhaps recognizing the true impossibility of Mars travel will redirect human ambition toward achievable goals that could actually improve life for billions of people. Instead of fantasizing about escaping Earth, we might focus on preserving and healing the only planet we'll ever have. The universe is vast and full of wonders we'll never reach. That's not a failure of human imagination or engineering. It's just the reality of existing in a cosmos governed by physical laws that don't bend to our desires. Mars will remain a beautiful point of light in our night sky, inspiring dreams and scientific curiosity from a distance, but it will not become humanity's second home. The physics of space travel, the biology of human survival, and the economics of interplanetary missions all point to the same conclusion. Mars travel is not just difficult or expensive or dangerous. It's actually impossible with any technology we could realistically develop within the constraints of human civilization and planetary resources. The Red Planet will keep its secrets, and humanity will keep its feet planted firmly on the only world that can truly support human life. And perhaps that's exactly as it should be.